This video is going to explain the process of multiplying binomials. And remember, a binomial is an expression with two terms. All like terms have been combined. This is an expression with two terms. So this is a layered up distributive property. Looking at the first example, I start with the first x and I distribute the first x to the first x in the second binomial. That's going to result in x squared, and I'll color code this. Then I move back to the first and I distribute the x to the 4 in the second expression. So that gives me 4x. So I've now distributed the x to both members. The first x has been distributed to both members of the second binomial. I now move back to the first and I pick up the 2. 2 times x, and then I move and I distribute the 2 to the 4. So I've tried to color code it so that you can see where each term is generated, how each term is generated. And now I've created a pair of like terms in the middle. I combine the like terms, and my simplified final expression is a quadratic trinomial, a degree 2. This example, it's not necessary to name them each time, but I will in this example. I have the degree 2, 3 terms, quadratic trinomial. And let's look at example number 2. So in example number 2, I'll do the same thing. I'm going to distribute the 2x to the first x in the second binomial. That gives me 2x squared. And then I distribute 2x to negative 5. That gives me negative 10x. And then I move back, and I'll change my pen. I'm now going to distribute the positive 1, and lastly to my constant. And once again, I've created the pair of like terms in the middle. I combine the like terms, so I have 2x squared minus 9x minus 5. That's my simplified product. Notice that it's already in standard form. The variables are all lined up in order. Let's look at number 1. So in number 1, same process, y times y, then y times positive 1, then move back and do the same thing with the 8, plus 8y, 8 times 1 gives me 8. Once again, you create a pair of like terms in the middle. You combine those terms, y squared plus 9y plus 8. Combine like terms, and it's already in standard form, power of 2, power of 1, and the constant with the power of 0. Let's look at number 3 with the negative sign. So I'll do the same thing, x times x, and then x times negative 4, and then I move back and I pick up the second member of the first binomial, negative 10, negative 10x, and then negative 10 times negative 4, resulting in positive 40. I combine my like terms in the center, and I have x squared minus 14x plus 40. My simplified expression. Let's look at number 7 on the video. So 3y times 3y gives me 9y squared, and then 3y times positive 2. Then move back and distribute the 1, and 1 times 2. Once again, creating a pair of like terms in the center. Combine your like terms, and the expression falls out already in standard form based on the exponents. And let's see, let's do a few more on the video, and I think I may want to stop the video and let you just practice and get good at this. So number 8, 6 times 2 gives me the 12, and then a times a, 12a squared. And then distributing the 6a to the 3, and then move back to the center, do the same thing with the 2, and then 2 times 3 is 6. And then once again, you've created the pair of like terms in the center. Combine your like terms. And you've got your quadratic trinomial. Let's look at number 10, and I think I may stop the video after number 10. So in number 10, erase around this. In number 10, I'm going to distribute 3w times 3w, giving me 9w squared, and then 3w times negative 1, and then I move back and I do the same thing with the positive 1, and then positive 1 times negative 1, giving me negative 1. So notice what happens to the like terms in this expression. Notice that the like terms in this expression are additive inverses. So they're going to zero out of the problem, and I'm only going to be left with 9w squared and a negative 1. So in this particular case, the terms in the middle, the like terms, are additive inverses, and they zero out of the problem. And I think that may be all that I want to do on this video.